the closing keynote, which will be given by Sudhi Hurl from Google, who has taken over the Android platform security team and has done a wonderful job with the security features of Android 11, some of which are can already be seen in the current beta. Sudhi, I wish you a very good morning to the West Coast as well, and over to you in Mountain View.
Hello, everyone. Good evening, good morning, as the case may be where you are. My name is Sudhi Hurl. I lead Android platform security, as Renee was mentioning. Today I will be speaking about icebergs in Android security privacy, trying to understand information asymmetry that exists in the platform and our users. I was really looking forward to being in Austria for this particular symposium and sharing a Radler with Renee, but unfortunately the COVID situation has made things very difficult for all of us. I hope you and your loved ones are safe and healthy. With that, let me get started into talking about my favorite topic here. Iceberg number one, preloaded applications. As you may know, there is a lot of media hype, media concern around security and privacy risk coming from pre-installed software. In point of fact, Privacy International sent a note to our CEO, Sundar, asking Google to take action against these exploitative pre-installed software on Android devices.
Sudhi, sorry for interrupting. We can't see your screen share yet.
Oh, you cannot?
At the moment, you cannot.
Can you see it now?
We see a screen share, but within the screen share, I see you at the moment. Perfect.
Can you see the second one now?
Yes, perfect.
Oh, sorry. As I was saying, Privacy International sent a note to Google, Sundar Pichai, asking Google to take action against these preloaded exploitative software. So, the question to ask right now is, what really is these preloaded application and why is it so bad? Well, every Android device ships with a lot of preloaded applications. They fall into broadly 5 categories. Mostly from the OEM, i.e. the phone manufacturer. We call them first-party applications. Some preloaded applications are from system-on-chip vendors. And oftentimes, they have the power to act on behalf of the Android platform, i.e. they enjoy very high privileges. The third category is a set of Google mobile service applications, which almost every OEM includes required by contract. This includes Google Play, access to the Play Store, Gmail, etc. And then there are carrier applications required by telcos. Typically, you need them for provisioning new accounts, voice over LTE, customer support, etc. And finally, the last category is third-party applications, which are none of the above, but are still preloaded on a mobile device. Many of these are risky due to the permissions they have. They're not, preloads generally aren't inherently bad. What makes them bad is the fact that the elevated privileges causes bad things to happen for the user. How do the OEMs preload the software? Well, they don't just bundle the APK. Some OEMs don't know what happens when something is signed with the platform key. And so, they sign these applications with the platform key, and now suddenly these third-party application, which was not written by the OEM, now has the power to act on behalf of the platform. In other cases, these preloaded applications have been pre-granted extremely large permission and privilege surface. Let's take a look at some real-world numbers. So if you look at Android 10 API level 29, and see across a variety of OEMs, what does the number of platforms and applications look like? For baseline, I'm looking at GSI, which is the Google System Image, which is the absolute bare minimum version of Android, i.e. AOSP plus Google mobile software that's required to run a phone. When you compare it against that, it has 53 platform signed applications. But across the ecosystem, almost every OEM that we benchmarked has vastly more platform signed applications. Well, I just now said that preloads aren't necessarily bad. What makes them bad is elevated privileges. So I'm going to double click a little bit on just one particular permission, install packages. And if you again look at the AOSP baseline and what's in GSI, we only have 3 packages there with the install package permission. But when you look at it across the ecosystem, some of the very large outliers include anywhere from 25 to 30 different applications that can install packages on behalf of the user. So we think this is problematic because users often don't know that these preloaded applications have these permissions, and therefore they are unable to make sense of what their device can or cannot do on their behalf. Well, the next question is, what can we do to improve the status quo? I think Rene, in his introductory keynote, shared some plans. We totally support that. We encourage the university and the research community to build a consumer-accessible transparency database to catalog these preloads and build a risk score chart across many devices and OEMs. This is especially important for consumers because information asymmetry. While we in the research community are fairly well versed in understanding what consent dialogues mean, what a VPN or a proxy means, and what certain permissions mean, the average consumer, by and large, has absolutely no idea. And so it falls to us, the research community, to raise the consumer awareness to this problem and provide a guided path for consumers to make safe purchase choices. As an analogy, when I go to buy tires for my car, depending on what type of car I have and what my road conditions are, where I drive every day, and what my skill level is, I can pretty much choose a very precise tire that is Z-rated, that has this kind of tread depth and this kind of grip and stopping power, etc. So regardless of whether you're a sophisticated car driver or not, there is a guided path for consumers to make the right purchase choice for their car tires. Now, analogously, we don't have that in Android. If a consumer wanted to make a purchase choice for an Android device based on their security or privacy stance, there is no guide that tells them what they should be looking for. And I'm really hoping that the research community and the consortium that Rene is trying to build will step up and provide this lighted path for consumers, and in some sense, close the information asymmetry that exists today. Iceberg number 2, firmware complexity. Well, here is a block diagram of a phone from a few years ago. If it's not very clear, I apologize. It's a very low resolution picture. We commonly think that a phone has one CPU, which runs Android. Many of you know that there is also a modem CPU. But what most of us seem to, in the back of our mind, we know, but we tend to ignore it, is that there are other things that also have quote unquote CPU in them. Your Bluetooth Wi-Fi controller, your GPS controller, your LCD controller, your USB controller, your DSPs that is used for modem, your camera ISP. All of these are little CPUs. Yes, there are CPUs everywhere on a modern phone. It's not just the ones that you commonly know, but there are lots and lots and lots of them. And they all run some kind of embedded software, typically called firmware. And almost always they are distributed as binary blobs by the manufacturer of that particular component. The interesting thing to ask here is, do we know what's in each of these blobs? Are they regularly updated with security fixes? Do they really come from the OEM or the chip vendor? Did anyone else interfere with them in the long supply chain from silicon vendor to OEM factory to end user? And also, from a security practitioner point of view, it's interesting to ask: are these images signed? Does those little tiny CPUs use verified boot to check the signature of each of these firmware blobs? What does this mean to the average consumer? Well, from the consumer point of view, it's useful to ask: did the system software on their phone really come from the manufacturer? Is the system software on their phone the same as the one checked by Google? Did the OTA update that they just received, was it broadly distributed to every user, or was it more narrowly built and targeted to some subset of users? These sorts of questions are really, really difficult to answer today. And this opacity that exists at the lower level is something that I'd like to call an iceberg, and requires more attention from the research community to fix what I call another information asymmetry here. The practitioners and the manufacturer of the devices have vastly more information than the consumer, whereas the consumer feels the impact of some of these decisions that we collectively, the community, make on their behalf. Finally, I get to my last iceberg, which is security UX. We all recognize that credentials are our most valuable digital asset. We use our credentials everywhere today, from ordering food to groceries, banking, investment, and in many countries, your access to government services is also done digitally. So safeguarding your credentials becomes the most important thing, right? Well, security non-experts have always maintained that you must use antivirus software, strong passwords, change passwords frequently. Well, all of you have probably worked in at least one company where you had an IT policy that says you must change your password every X number of weeks. Whereas when you look at security experts, what they recommend as safe online practice, it comes to very boring stuff. Install software updates regularly. Choose unique passwords for each service that you use. Oh, and for the love of everything that is nice and holy, please use two-factor authentication, and use strong passwords, and use a password manager. Don't write things down, right? So we as practitioners, we follow these sorts of guidelines, but every now and then we log into our favorite service from a different computer, and then the system throws up all kinds of alerts and safeguards and says, prove to me who you are, right? While some services do a very good job of identifying users coming from a potentially different place than what the system thinks the user should be coming from, it's not always obvious. Even some of us who are very sophisticated sometimes receive an email that says, my billing, that there is some difficulty with billing. Would you please click here and update? Right? Imagine getting this email while you're watching a show and you got up to get a drink or a glass of water or whatever. You check your phone and here is this email. Well, how many of us actually take a pause, go back to our desktop, open this email, look at the URL, and say, aha, this is a phishing email. I must not click, right? Our first instinct is to look at this. Well, it looks like Netflix. Well, it kind of looks like the Netflix red button. And it says your friends at Netflix. So it must be true. Let me click on it. Right? My point is that stressed humans are cognitively impaired. And these stresses and stressors occur in our day-to-day life when we're doing a lot of, when we're using our mobile phones in everyday scenarios. And information asymmetry does not help this situation. If you're not an expert or a security expert, it is really difficult to counter some of these attacks that have become really, really sophisticated in modern times. I guess the answer to this is for us to pay attention to the user experience when we throw up security alerts or caution dialogues or change the workflow because of a suspected security incident. We need to make sure that we think about the information asymmetry between the practitioner and the user on the other side. I want to close with a example of what happens when you close information asymmetry gaps. In 2007, there was a research article in the Quarterly Journal of Economics where the author explores information asymmetry that existed in the fisheries segment in the state of Kerala, India. So prior to the introduction of mobile phones, I'm talking mobile phones, not smartphones. So this is 2007, the year that the first iPhone was introduced. And in India at that time, the feature phones were still pretty common. And so before the introduction of these mobile phones, there was tremendous price variability in the spot price of fishes in different regions within a single state in India. And the chart on the left shows you the gradual ramp up of mobile phones. The moment the penetration achieved close to 100%, you can see correspondingly the price variability also dramatically dropped. Right? In hindsight, this seems obvious, but to me, this is remarkable example of how closing information asymmetry gaps leads to beneficial effects for our consumer. When we think about security and privacy, it's not just an algorithmic process or a cryptography or a legal policy compliance, etc. We absolutely must seriously consider the human angle of it as well. So there is need in the research community to focus on the humanist side of security and privacy. We must think holistically about security and not just get stuck in the weeds. And we should always pay attention to the consumers. Thank you. And if you have questions, I'm happy to answer them. Otherwise, I hope to give back some time. We seem to have ended at 9 a.m. Precisely on time. Thank you.
Thanks a lot. Thank you so much, Sudhi, for that closing. I am watching our chat for questions right now. Right. If anybody has questions, just please also use the raise hand feature in Zoom, or just simply unmute yourself here. So I will, while people are still typing, you mirrored something that Alex has said in his keynote before, the issue of complexity. One of your icebergs that I'm fully on board with is complexity, and how specifically for modern phones, this seems to be exploding and actually getting worse year over year, both for hardware and software, be that firmware or what we typically call the system software. Where do you see this going? So how do you think we can manage to cope with this complexity? Or would you say that we just have to deal with rising complexity and mitigate, make small pockets of lower complexity and deal with those instead? What do you think? Where are we heading, or maybe where should we be heading?
So my fear is that the security community is not uniformly distributed across different micro segments within our field. For example, one might say that people who make merchant silicon system on chips and folks like Google Android team, we may have excellent security engineers, but the same possibly cannot be said of smaller players that make LCDs, LCD controllers, or smaller companies that make a dedicated chip for doing some particular task. And the reason why I think I'm mostly right is these smaller players show up in the IoT segment very, very frequently. And if you want to see where the broader information gap exists, all you have to do is look at the IoT segment and see how many of them practice safe security practices. There was an article in ZDNet that I read a couple of days ago that said majority of consumer routers worldwide never receive security updates. Right? For us, this is mind-blowing because we think that this is a solved problem. We have tools, we have well-known techniques for doing Delta-based software updates, right? You have orchestration systems, multiple open source orchestration systems for doing over-the-air firmware update, yet nobody does this, right? If we dig deeper, I suspect we will also discover that as you go lower into the firmware stack, basic things like secure verified boot may also be missing, right? So the answer may be that we need to educate the next generation of students and researchers and practitioners to think about security from the ground up and know what are these constructs and make sure there is an opinionated path for some of these security constructs. When Google discovered that TLS SSL is a foundational element for the web, and OpenSSL would have every alternate Tuesday with a new bug report. Somebody at Google called Adam Langley decided that security needs to be boring. They created a boring version of OpenSSL and called it Boring SSL. I'm wondering if a similar boring security approach needs to be taken for a variety of narrowly scoped components across our technology stack, right? Eliminate the complexity associated with choice and provide narrowly scoped answers to common problems. Maybe that's a good starting point.
Thank you. We have a first question by Daniel, who is also, I think, still dialed into the meeting. Daniel, do you want to ask yourself?
Okay, so you talked about credential stealing and basically phishing on mobile, which is, I think, worse than on desktop, mostly because there's not enough screen real estate to show as much detail. So how do we address phishing on mobile?
That's a very good question. I don't have answers, but my intuition is that we need to do much more user studies, UX experiments to see what is the best way to surface this. It's not entirely obvious to me what is the right answer here. The reason I raise these problems is because I don't have answers. I'm really hoping that the research community can invest a little bit of time thinking about the user experience of security issues and come up with hypotheses and test them. Rene, do you have a better answer than this?
I agree with Daniel that probably for mobile devices, the hard part is real screen estate, which maps back to what you also said in your talk, that attention is one of the key elements. How do we manage attention for users who are attention overloaded, who are stressed? Maybe the answer goes back to what you said in reducing stressing factors, stressors, to be able to allow to concentrate on the right things. But again, I don't have a good answer, because that question on how to surface the right amount of information on a very small screen, I think has existed since we had devices with small screens, since we had first smartphones. Unfortunately, I don't have a good answer to that either, besides trying out different things, trying out how we can surface the right amount of information, which incidentally actually maps to the second question that we had pretty much at the same time in the Q&A chat by Paul Blundell, who I don't see dialed into the Zoom meeting, so I'll just read it. Do you feel the Android permission system is a success? If you could step back 10 years, what would you do from the start differently? I love that question because hindsight is such a good thing, specifically in security. So, Sudhi, what's your take?
This is an excellent opportunity for me to put my foot in my mouth. This is a very, very good question. You know, in hindsight, I wish we were a little more diligent in thinking about all sorts of permissions, their interactions, and how do you determine which of these permissions require user consent versus not, and how do you surface these consents to the user. I wish there was a little bit more understanding back then. I'm not saying people didn't think about it. Because Android was so new, because smartphones were so new, the available information space for you to wander in was obviously very limited, right? But if in the future we have a chance to do so, I think a good way to look at it is to partition permissions into those that are sensitive, and which of these require user consent, strong user consent, which of these deal with private data, right? Figure out a few of the axes that are important and try to put each of the permissions in some hypercube, n-dimensional hypercube, so we can reason better about them. Right? Today, they're all in a flat space, and it makes reasoning very difficult. And because of backwards compatibility reasons, we are forced on an incremental approach of solving the problem. It'd be interesting to see if somebody in the research community totally rethinks the whole permissions thing without worrying about backwards compatibility or forward compatibility, and reimagine what is the right way to present this information and build a prototype. Might be very interesting to see what we learn from that exercise.
Yeah, I can think of one particular example where many of us are probably now eating our words, or feeling that had we known about the current situation, we would have decided at least that one tiny thing of permissions grouping differently, which is the BLE beacon scanning permission in the location group, right? With all the exposure notification apps, the contact tracing apps out there, that has become a major hurdle to adoption, that they have to ask for the location permission group for very good reasons. Historically, there were good reasons why this was put in that group, but right now it's the wrong grouping. And so, yeah, I totally agree. I think that those will have to change and will have to be redefined as we go on.
Yeah. And I really think the research community has an opportunity here to reimagine the world and present some results, good or bad, of how this could be rethought, right?
Mm-hmm. We have another question in the chat from Martin. Is reducing information asymmetry something that drives the design of security controls in Android?
Yes, I think so. I think a large part of our day-to-day conversations is around how do we make the user really understand the choice presented to them, and is the choice comprehensible to the average user, not one living in Bay Area building Android devices, but really one of our 2.5 billion users worldwide. Can they really understand when they say allow for a particular permission? Do they understand what that means? And we also spend a lot of time thinking about information asymmetry that exists between application developers and the platform developers. And how do you make sure that certain APIs cannot be abused or misused, right? Either intentionally or accidentally, more often than not accidentally. And so we spend a lot of time thinking about what a particular feature means to its constituent, be it the developer or the consumer. I don't know if I answered that question, but yes.
I think so. I'm just double checking the chat to see if we have any other questions. I think people are still typing. So as we are nearing the end of this symposium, I guess this is a case of last call for questions. We can, of course, also take them offline. So that's something that I'd like to encourage all participants to still use the virtual conference venue even after we close the live stream, because this dedicated chat system instance will remain open. And feel free to just keep using it for at least a week or so to either interact, to connect with each other, or to just continue asking questions in the Program Day 1 or Program Day 2 Q&A session chats. And authors can then maybe just answer those questions also in textual form. Otherwise, Sudhi, thank you so much for doing this. Thank you so much for closing our Android Security Symposium with this talk. I'm also pretty sad that we couldn't have you over here in Linz. Even the weather has turned out nice, very nice today. But the promise still stands. We will have proper food, proper drinks over here in Austria. I'm certain that there will be other chances to do so. And of course, we're all hoping for the travel situation to clear up somewhat.
Yes, indeed.
When that happens, nobody knows. But I'm optimistic, I'm positive it will happen, and then we will get you over here to Austria and show you the sites. That's a promise that still stands.
Excellent. Thank you so much. I look forward to it. And thank you for having me, Rene.
Yeah. Thank you, Sudhi.
Thank you for everyone for helping me with everybody in the JKU staff who helped put together the symposium. And
yeah. Thanks, Sudhi. I wish you a great day back at the West Coast.